Hello and welcome to Leadership Emotional Development LLC. This is the second core level workshop from our system theory group, especially designed for leaders of all industries. This workshop will provide you with the theories of decision making and the procedures to develop a precise analysis so you can make better decisions and apply them in your leadership career to become the successful transformational leader you deserve to be. Corporate decision making is successful as long as there is a glue to bind the organization together in the form of charismatic leaders or an organizational culture that values coherence and imposes stability. Once any of these conditions are removed, organizations will then fall into a self-defeating trap wherein the process of corporate decision making is impaired, leading to the loss of competitiveness of the company. But strong leaders are known for recovering quickly from the ramifications of poor decisions. They think of a decision as a step to learn and grow from, and do not get bogged down in self-pity or a mirror of failure. To recover quickly, they must learn and master the mechanisms of decision-making process. This workshop will provide you with these tools so you can lead effectively at all decision-making process levels. This workshop will introduce 7 modules. The modules are as follows. Module 1, Mechanisms of Decision Making. Module 2, Concepts of Decision Making. Module 3, Basic Principles of Probability. Module 4, Decision Environments. Module 5, Decision Making Analysis. Module 6, The Future of Decision Making. And Module 7. Here, we'll be wrapping our workshop. Module 1, Your Action Plan. Before we start our workshop, we believe this is the best time for you to begin taking notes. In your workshop notes, please write the concepts, philosophy, models, formulas, trends, examples, and results that you will later need to put together a decision-making plan. This workshop will help position yourself in your organizational future goals as you become the transformational leader you deserve to be. Okay, let us begin. Mechanisms of decision making. In today's overly complex organizations, rational and behavioral decision making has impacted leadership's basic principles, their ethics, their group dynamics, and the critical risk assessments needed to make us better leaders. Many leaders choose not to follow the basic mechanisms of decision making, and by doing so, they continue to misinform followers, thus creating confusion and unnecessary chaos among them. This is why it is absolutely essential that you and I get a clear understanding of the following subjects. This module will begin by providing the workshop description, workshop perspective, workshop objectives, the role of decision makers, the levels of decision making. In this module, you will learn about decision-making process, which is regarded as a continuous process integrated in the interaction with the environment around you. That means we will emphasize how your decision-making process will impact your organization and your personal career objectives. Workshop description. Throughout your life, you will have opportunities to make decisions in personal, educational, and business situations. You will often learn from these experiences and become better at making decisions. Fortunately, many of the simple decisions you make become almost automatic, and you might get to the point where you do not have to waste much time or mental energy on them. When this happens, you might have a difficult time understanding or explaining how you arrive at the decision you made. Because the decision-making process can become automatic, you may be surprised that it is possible to fall prey to a variety of biases and traps. For these reasons, this workshop begins by providing you first with the perspectives and objectives of the course so you can get a better idea of its structure and format. And second, by providing you with the theories and techniques that will allow you to analyze and justify decision making through process when elaborating your decisions. Hopefully, this experience will help you to become a better leader and a better decision maker, personally, educationally, and professionally. Workshop Perspectives. We designed this workshop to provide leaders with a better understanding on how to apply the mechanisms of decision making, teaching them to adopt the concepts of decision making and applying them as they make their own decisions, understanding the role of management and its impacts through the decision making process, implementing decision making process by using the principles of probabilities, learning how and when to apply our decision-making analysis correctly, and of course study the latest advancements in artificial intelligence features incorporated into the decision-making process functions. Therefore, understand the direction many industries are taking now after COVID-19. Workshop Objectives. The objective of this workshop is to prepare the leaders to apply appropriate decision-making models, tools, and techniques such as forecasting, inventory control, quality control, scheduling, and optimization for structured and unstructured management problems. Assess common myths and shortcomings in decision-making. Estimate future conditions as part of our decision-making process. Plan the right alternatives and payoff under future conditions during our decision-making process. Assess alternatives according to appropriate decision criteria. Evaluate decisions by individuals and by groups. And develop plans to communicate and execute good, sound decisions. The role of decision-making. Every organization has its own decision-making process. The process is partially shaped by the environment the organization is facing. So we must begin by asking ourselves the context of the environment we face. What is the issue? What kind of culture are we facing? Who are the stakeholders? The macro context. This is the big picture stuff, such as what the laws or regulations require. If the policy says a decision has to be made by the board of directors, the executive group at the factory, or a supervisor, then that is the way it has to be done. The meso context. What is the organization culture? Some companies want employee feedback for decisions that affect them. In other organizations, upper management hands down its decisions from on high. The micro context. This is the immediate environment. The decision-making process changes depending on whether you are in a meeting with investors, employees, or customers, for instance. Decisions are made at every level of management to ensure organizational goals are achieved on time and within budget. Decisions play important roles to achieve organizational and managerial objectives, to ensure optimal growth and drivability in terms of service or product offer. Levels of decision making. Strong leaders are savvy about all levels of the decision-making process. To be most effective in all levels, leaders must be fully transparent about what levels they are using and why. Here are the levels. Level 1. This is used in situations when immediate action needs to be compliant and without hesitation. This is when the leader is in the best position because of clarity of knowledge to make the decision. Level 2. Input from others assists by providing information to cover blind spots so the leader may better understand the depth of the issue to be decided. The leader reserves the right to decide independently once appraised. Level 3. At this level, the leader calls on an expert group or sub that can work on behalf of the entire team or organization to provide recommendations. The smaller group has representative knowledge. The leader decides once recommendations are reviewed. Level 4. There are appropriate times when the entire team must weigh in on a decision, as when dissenting opinions too difficult to reconcile. Debate clarifies the issues so a vote can be taken and the decision implemented. The leader must use the decision as an opportunity for development. Level 5. Here, the leader fully delegates the decision to a group and becomes one of many. The group discusses, discerns, and decides on behalf of the organization. Gathering a consensus is a process not to be rushed. Because it means compromise, it must continue until all agree to leave with their right decision. Module 2. Concept of decision making. Depending on the role you play in an organization, you will find yourself faced with different kinds of decisions at different frequencies and impacting both the inside and the outside of the organization. Understanding the various levels of an organization, the decision environment, and types of decision is crucial for anyone studying managerial decision making. In this module, you will learn about the concept of decision making, what is decision theory and its characteristics, examine the decision making process, understand about the risk you will confront as a decision maker, and situations you might encounter in an organization when poor decisions are made. So let us begin. Decision making. What do managers and leaders do? They do not really do the actual work of an organization, but primarily what they do is to make the decisions necessary to allow the people who do the work to do it as effectively and efficient as possible. Decision making is the process of identifying and choosing alternatives based on the values, preference, and beliefs of the decision maker. But the more important things to consider before even beginning to make a decision includes figuring what the problem is, how important the decision is, how many available resources it would take to implement the decision, and when would the decision be made. Leaders and managers will hopefully learn how to make the right decisions by taking the right course of actions and see these actions as the beginning of a lifelong journey to become a better decision maker. Decision theory. Decision theory represents a general approach to decision making. This theory is appropriate for a wide range of operations management decisions. Among many operational decisions, we find issues of capacity planning, product and service design, equipment research and selection, and the mitigation of location planning. Decisions that lend themselves to a decision theory approach tend to be characterized by the following elements: a set of possible future conditions. This will have a bearing on the results of the decision. A list of alternatives. This is so we can have a list of alternatives to choose from. A known payoff for each alternative. This is to look at alternatives under each possible future condition. Decision-making process. For a leader to implement a correct decision-making process, he must follow this procedure. Number 1, identify the problem. To begin the decision process, you must first identify the problem you need to resolve. Clearly define your decision. Number 2, define the solution criteria. Do an internal and external assessment. Seek where your organization has succeeded and failed in areas related to your decision. Number 3, develop a list of possible alternatives. With relevant information now at your fingertips, identify possible solutions to your problem. There's usually more than one option to consider when trying to meet a goal. Number 4, estimate payoffs associated with each alternative. Weigh the evidence for or against said alternatives. Identify potential pitfalls for each of your alternatives and weight those against the possible rewards. Number 5, evaluate among alternatives. Here is the part of the decision-making process where you make the decision. You are perfectly prepared to choose. Number 6, implement the solution. Develop a plan to make your decision tangible and achievable, and then set the team loose on their task once the plan is in place. And number 7, monitor to see that desired results are achieved. After a predetermined amount of time, take an honest look back at your decision. Did you solve the problem? Did you answer the question? Did you meet your goals? If yes, then you're good. If not, learn from your mistake as you begin the decision-making process all over again. The payoff table. The information for a decision is often summarized in a payoff table, which shows the expected payoff for each alternative and the various possible states of nature. These tables are helpful in choosing among alternatives because they facilitate comparison of alternatives. Consider the following payoff table, which illustrates a capacity planning problem. In this example, the payoffs are in terms of present values, which represent equivalent current dollar values of expected future income less cost. If a small facility is built, the payoff will be the same for all three possible states of nature. For a medium facility, low demand will have a present value of 7 million, where both moderate and high demand will have present values of 12 million. A large facility will have a loss of 4 million if demand is low, a present value of 2 million if demand is moderate, and a present value of 16 million if demand is high. The problem for the decision maker is to select one of the alternatives, taking the present value into account. Evaluation of the alternatives differs according to the degree of certainty associated with the possible future conditions. Risks of decision making. A well-designed risk-response portfolio will focus not only on reducing the likelihood of a risk occurring, but also include plans for stabilization and recovery to ensure business continuity and effective reputation management. A typical evaluation tool to use during a decision-making process is called the risk-based decision-making process, in where the issues are defined, the options are examined, and the decision implemented. The process begins with the identification of the risk response options, followed by an evaluation of the identified risks. The identification process of a risk response options is based on 4 T's. We must begin by questioning if the risk is worth pursuing, if taking the risk will be cost effective, if this risk reward acceptable, and what will be the financial impact by taking this risk. The evaluation process of the risk response options will take into account the cost benefits, the views of relevant stakeholders, the mandatory requirements imposed by internal standards or external regulatory authorities, And how hungry are you to take the risk response, which it is not cost effective, would normally be discarded. Successfully applying the risk-based decision-making process can be both powerful and cost-effective. Making poor decisions. Unfortunately, many business leaders are not particularly good about making decisions. They either rush through the steps, many times skipping the steps, they get stuck on evidence, never move on to the next step, and end up with a bad decision. Here are some of the reasons why. The leader fails to check the facts, get surprised by unexpected events, get confused with the complexity of the decision, has no strategy in place, fails by not following the decision-making process correctly, does not react on negative results and continues to ignore them, get stuck on other issues of concern such cost, time, technology, gets confused with other groups' suggestions, fails to communicate forward the final decision. It is sometimes difficult to see our own faults in decision making until we hear or read about similar situations. But the worst thing that a leader can do is not make a decision at all. So focus in your options and make your decisions using your logical mind and remembering to follow your decision-making process steps correctly. Module 3: Basic Principles of Probability. In the heart of a decision-making process, businesses apply the understanding of uncertainty and probability in their business decision practices. This is because it provides the means to rationalize models, analyze them, and solve problems where future events cannot be foreseen with certitude. Probability models can greatly help business in optimizing their policies and making safe decisions. Though complex, these probability methods can increase the profitability and success of a business. In this module, we will introduce the theory of probability, its possible outcomes, sets, and their logical operands, how to interpret axioms, and how to interpret probabilities. So let us begin by describing the theory of probability. Theory of probability. The theory of probability provides the means to rationally model, analyze, and solve problems where future events cannot be foreseen with certainty. In numerous managerial decisions problems, especially those with strategic implications, it is not possible to ascertain the results to obtain when choosing a course of action. In such cases, if one wants to act rationally to maximize the chances of attaining one's goal, it becomes necessary to explicitly deal with the uncertainty posed by the problem. Thus, probability theory is indispensable for rational decision making. The fundamental concepts of modern probability theory are truly grounded on sets theory. It is of an essence to define the theory of sets along with some basic related terms here. Set. Set is defined as a collection of elements. It's usually represented by listing their elements within braces, or by stating some condition the elements must satisfy to obtain membership in the set. Subset. This is a set within a set, where each element is also a member of the main set. Outcome. This is the actual result obtained from engaging in a specific activity. Event. This is a set of possible outcomes. The two types of events can be compound event, a set of consisting of two or more possible outcomes, an elementary event, a set of consisting of only one possible outcome. The analyst should always keep in mind that events are subjective categorizations considered by the analyst to be relevant to the problem. Conditions of possible outcomes. Let us begin by defining a universal set, also known as the event space or outcome space. The universal set is the set that shows all possible outcomes in a given problem. This set is typically denoted by the letter U. There are two conditions on this universe of possible outcomes. The outcome must be mutually exclusive. This means that only one outcome can occur at any one point in time. When defining the universal set of a given problem, one must ensure that there are no overlaps and ambiguities among the constituent outcomes. The outcome must be collectively exhaustive. This means that the universal set must include all eventualities relevant to the problem at hand. The implication is that one of the outcomes will eventually occur in due course. Thus, when defining the universal set, one must ensure that all potential outcomes that could conceivably occur are included in the universal set U. Remember that every universal set is a collection of mutually exclusive and collectively exhaustive outcomes, and that one and only one outcome will ultimately occur. Events, however, contrary to outcomes, may or may not be mutually exclusive. This follows from the fact that events are collections of outcomes and that any given outcome can, in principle, be categorized as belonging to more than one event as shown here. Venn diagrams. The Venn diagram is a good tool that provides visualization of the sets and their operations. Here, the universal set of outcomes, U, is typically depicted as a rectangle. The points within the rectangle represent the possible outcomes associated with the activity of interest. Since U represents the totality of possible outcomes associated with a certain activity, we define its area to be 1, meaning it contains 100% of the possibilities. Thus, U indicates that the set of possible outcomes is collectively exhaustive, and since its points do not overlap, they, and the outcomes those points represent, are taken to be disjoint or mutually exclusive. An event E is usually depicted as an arbitrary circle within the universal set of outcomes named U, and its size is also irrelevant. This diagram can be used to portray the situation described in this example, where the activity was the roll of a die and E was the event even, 2, 4, 6. Note that E is a subset of U, 1, 2, and so forth till 6. This is shown on the diagram by the fact that the circle E is wholly contained within U. Logical union sets. There are two fundamental logical operations performed over sets, and they are known as union and intersection. The union of two sets, A and B, is denoted A union B, and is itself a more inclusive set containing all elements that belong to A or to B. This, of course, includes those elements that belong to both A and B, if any. The union symbol V stands for the logical operator OR. Thus, A union B can also be read as A or B, and is sometimes written as A plus B. Here, A union B groups all the elements that are members of either one of the sets, even if the sets are disjoint, that is, even when they are mutually exclusive, share no comment elements. Logical intersection sets. The intersection of two sets A and B is denoted as the symbol A intersect B, and is itself a more exclusive set containing only those elements that belong to both A and B. The set A intersects B is simultaneously a subset of A and a subset of B. The intersection symbol you see between set A and set B stands for the logical operator name AND. Thus, A intersect B can also be read as A and B, and is sometimes written as A times B or simply AB. Note that if A and B are mutually exclusive, A intersect B equals 0. The name is the null set or empty set because there are no elements common to both A and B. Therefore, the sets are disjoint. By definition, the null set 0 is a subset of every set. The null set is not depicted on Venn diagrams, for it has no points in the universe U. Introducing axioms. The theory of probability, like all branches of mathematics and logic, builds upon a set of axioms or postulates. An axiom is a foundational principle that is not demonstrable, but it is considered to be self-evident. The following version of Kolmogorov's axioms proposes that U is the universal set of outcomes, that U is finite, and that A and B are any two events defined within U. Let us study about them. The first axiom specifies that the probability of any event A is non-negative real number. The second axiom states that the probability that some outcomes will occur is 1, meaning it is 100% certain. This implies that all possible outcomes relevant to the problem are contained in U. Thus, U is collectively exhaustive. Taken together, axioms 1 and 2 restricts the range of probabilities of event A being equal or greater than 0, but equal or less than 1. The third axiom states that the probability of the union of two events is the sum of their respective probability minus the probability of their intersection. We will now go into a third event due to the exhaustive mathematical functions, not practical here for this exercise. Axioms of probabilities. Kolmogorov's original axioms differ in presupposing that the event space U is infinite. Although this assumption is of paramount importance for the completeness of the mathematical theories of probability, it is not particularly relevant to the finite problems typically encountered in managerial decision-making contexts. Therefore, we concluded that the final set of axioms for any events A and B and the universal set U are as follows. First, the probability of event A being equal to greater than 0 but equal or less than 1, so the range is from 0 to 1 only. Second, the probability of the universal group would be equal to 1. Third, the probability of 0 will be 0. Fourth, the probability of A union B is equal to the sum of the probability of A and the probability of B minus the probability of A intersect B. And fifth, the probability of A not is equal to 1 minus the probability of A. These are known as the Kolmogorov's classical axioms, which will be used on our decision-making process. Interpreting probabilities. The classical approach relies on the axioms of probability, along with essential definitions and the logical structure of the given problem to determine the probabilities of events. No empirical data, such as obtained by the statistical sampling, or intuitive judgments regarding likelihoods are required. Probability assessments are obtained by logical analysis of the problem situation, with the additional condition that all outcomes are assumed to be equiprobably. It is called classical because it follows from the original interpretation given to the notion of probability in relation to games of chance. The classical approach assumes that all outcomes are equally likely to occur. Thus, if there are n equally likely possible outcomes from a given process and one of the outcomes must occur, the following probability assignments hold true. 1. Each outcome has a probability of occurring equal to 1 over n. 2. If an event A is defined as consisting of m such outcomes, then the probability of A equals m over n. The first statement should be intuitively obvious in accordance with axioms 1 and 2. The second statement follows that the fact that since the outcomes are mutually exclusively elementary events, here the generalized version of axiom 3 applies. This shows the steadfast relationship that exists between the classical approach and the axioms of probability. Module 4. Decision Environments. Decision-maker environments can play a part in the decision-making process, Studies done have shown that more complex environments correlates with higher function, which means that a decision can be influenced by the location. Cognitive functions are greatly affected by the higher measure of environmental complexity, making it easier to think about the situation and make better decisions. In Module 4, we will be focusing on those decision-making environments. You will learn about a certainty and uncertainty environments, learn about making decisions under a risk environment, and learn about how to respond to those environments using techniques like the payoff tables analysis and the decision tree analysis. So let us begin. Decision-making environments. In the field of management, strategic management involves the formulation and implementation of major goals and initiatives taken by an organization's top management and based on consideration of resources and assessments of the internal and external environments in which the organization operates. Operations management decision environments are classified according to the degree of certainty present. There are three basic categories: certainty, risk, and uncertainty. Certainty. This is the environment in which relevant parameters have known values. Risk. This environment is the one in which certain future events have probable outcomes. Uncertainty. These environments are the ones in which it is impossible to assess the likelihood of various future events. The importance of those different decision environments is that they require different analysis techniques. Some techniques are better suited for one category than for others. Decisions under certainty. When it's known for certain which of the possible future conditions will actually happen, the decision is usually relatively straightforward. Simply choose the alternative that has the best payoff under the state of nature. Here, we are asked to determine the best alternative in the payoff table. Thus, if we know the demand will be low, we will elect to build a small facility and realize a payoff of 10 million as we shown inside the red window. If we know demand will be moderate, a medium factor will yield the highest payoff, 12 million versus either 10 million or 2 million. For higher demand, a large facility will be provided the highest payoff. Notice that in some instances, there may be an opportunity to consider allocations of funds to research efforts, which reduce or remove some of the uncertainty surrounding the states of nature, converting uncertainty to risk or to certainty. Decisions under uncertainty. At the opposite extreme is complete uncertainty. No information is available on how likely the various states of nature are. Under those conditions, there are four possible decisions criteria, and they are the maximum, the maximax, the Laplace, and the minimax regret. Let us define them now. The maximum. This criterion determines the worst possible payoff for each alternative and chooses the alternative that has the best worst payoff. The maximum approach is essentially a pessimistic one because it considers only the worst possible outcome for each alternative. The actual outcome may not be as bad as that, but this approach establishes a guaranteed minimum. The maximax. The maximax criteria determines the best possible payoff and choose the alternative with that payoff. The maximax approach is an optimistic go-for-it strategy, and it does not consider any payoff other than the best. The Laplace. The Laplace determines the average payoff for each alternative and chooses the alternative with the best average. The Laplace approach treats the state of nature as equally likely. The minimax regret. The minimax regret determines the worst regret for each alternative and chooses the alternative with the best worst regret. This approach seeks to minimize the difference between the payoff that is realized and the best payoff for each state of nature. We will now illustrate how these decisions criteria are handled. The minimax regret. The minimax regret determines the worst regret for each alternative and chooses the alternative with the best worst regret. This approach seeks to minimize the difference between the payoff that is realized and the best payoff for each state of nature. The maximin, maximax, and Laplace. We will be referring here to the same payoff table previously presented, looking at all three strategies to determine how each of them behave with each alternative. We see the following. With the maximum strategy, we look at the worst payoff, which typically happen during low demands. So looking at the column demand, it shows for a small facility the payoff is 10 million, for a medium is a 7 million, and for the large is negative 4 million. The best load here is 10 million, so build a small facility. With the maximax strategy, we will look at the best payoff under the high demand column, and we have here 10 million for the small facility, 12 million for the medium facility, and 16 million for the large facility. Here, the best payoff is 16 million, so build a large facility. For the Laplace criterion, create a Laplace table as follows. Sum each alternative from left to right and locate them in the row totals, as shown in the Laplace table here. Get the average of each of them by dividing each of the results by 3, which is the number of demand options, or better known as the state of nature. Select the highest average, which is, in this case, 10.33 million. So build a medium facility based on Laplace. Now let us look at the minimax regret. The minimax regret. This strategy first determines the worst regret for each alternative and then choose the best worst to decide what the ultimate alternative is. The procedure is as follows. Prepare a table of regrets or opportunity losses to summarize your results. Begin by subtracting every payoff in each column from the best payoff in that column. This means in the first column, the base payoff is 10, so each of the 3 numbers in that column must be subtracted from 10. Going down the column, the regrets will be 10 minus 10 equals 0, 10 minus 7 equals 3, and 10 minus 4 is equal to 14. Thus, these numbers in the first column of the regret table must be written. In the second column, the base payoff is 12. Subtracting each payoff from 12 yields 2, 0, and 10. These values will be going in the second column of the regret table as well. In the third column, 16 is the best payoff. The regrets are 6, 4, and 0. These values will go in the last column of the regret table. The second step is to identify the worst regret for each alternative. For the first alternative, the worst is 6. For the second, the worst is 4. And for the third, the worst is 14. The best of these worst regrets will be chosen using minimax regret. The lowest regret here is 4, which is the best worst payoff for a medium facility. Hence, let's build a medium facility. Decision making under risk. Risk exists between two extremes of certainty and uncertainty. The probability of occurrence for each state of nature is known. Because the states are mutually exclusive and collectively exhaustive, this probability must add to 1. A widely used approach under such circumstances is the expected monetary value EMV criterion. Here, the expected value is computed for each alternative, and the one with the best expected value is selected. The expected value is the sum of the payoffs for an alternative where each payoff is weighted by the probability for the relevant state of nature. Let us look at this approach together. First, we will multiply each alternative, small, medium, and large, by its corresponding probability of occurrence, 0.30, 0.50, and 0.20 for each state of nature, low, moderate, and high, and place them in the table as shown here. Second, add each state of nature results for each alternative and select the highest expected value. The highest expected value is 10.5, so choose the EV median value. The EMV approach is most appropriate when a decision maker is neither risk adverse nor risk seeking, but is risk neutral. Well-established organizations with numerous decisions of this nature tend to use EMV because it provides an indication of the long-run payoff. That is, the expected value amount is not an actual payoff, but an expected or average amount that would be approximate if a large number of identical decisions were to be made. Therefore, if a decision maker applies this criteria to a large number of similar decisions, the expected payoff for the total will approximate the sum of the individual expected payoffs. Decision trees. Decision trees are tools that have many practical applications in a wide array of management decision making, including return on investments and risk analysis, making decisions on new products or service development, and location analysis during the analysis of capital expansions. These are characteristics of decision trees. A decision tree is a schematic representation of an alternative available to a decision maker and their possible consequences. The term gets its name from a tree-like appearance of the diagram. Decision trees are particularly useful for analyzing situations that involve sequential decisions. A decision tree is composed of a number of nodes that have branches emanating from them. Square nodes denote decision points, and circular nodes denote chance events. Read the tree from left to right. Branches leaving square nodes represent alternatives. Branches leaving circular nodes represents chance events. After the tree has been drawn, it is analyzed from right to left. That is, starting with the last decision that might be made. If chance events follow a decision, choose the alternative that has the highest expected monetary value or lowest expected cost. Decision tree analysis. In this exercise, a manager must decide on the size of a video arcade to construct. The manager has narrowed the choices to 2, large or small. Information has been collected on payoffs and a decision tree has been constructed. Analyze the decision tree and determine which initial alternatives, build small or build large, should be chosen in order to maximize expected monetary value. In this exercise, it is important to notice the following before analysis takes place. The dollar amount at the branch ends indicates the estimate paid off if the sequence of chance events and decisions that is traced back to the initial decision occurs. For example, if the initial decision is to build a small facility and it turns out that demand is low, the payoff will be $40,000. Similarly, if a small facility is built, demand turns out high, and a later decision is to expand, the payoff will be $55,000. The figures in parentheses on branches leaving the chance nodes indicate the probability of those states of nature. Therefore, the probability of low demand is 0.4. The probability of high demand is 0.6. Payoffs in parentheses indicate losses. Decision 3 results. Analyze the decision from right to left. We will determine which alternative would be selected for each possible second decision. For a small facility with high demand, there are 3 choices: do nothing, work overtime, and expand. Because expand has the highest payoff of $55,000, you would choose it. Indicate this by placing a double slash through each of the other alternatives. Similarly, for a large facility with low demand, there are 2 choices: do nothing and reduce prices. You would choose reduce prices because it has the highest expected value of $50,000, so a double slash is placed on the other branch. We then determine the product of the chance probability and their prospective payoffs for the remaining branches by selecting the building small and building large options and calculate their lows and highs demands by multiplying probabilities by their respective payoff as we display in the table. Once these values are obtained, we determine the expected values of each initial alternative by adding their build small and build large demands and come up with 2 final values. Build small came out to be $40,000 and build large was $62,000. Hence, the choice should be to build the large facility because it has a larger expected value than the small facility. Module 5. Decision-making analysis. Decision modeling and analysis represents a general approach to decision-making. It is suitable for a wide range of operations management decisions. Among them are capital planning, product flow design, automation, and selection of new technology, and of course, expansion due to capacity and modernizations. This module will introduce how influence diagrams help in complex situations, introduce the difference between the expected payoff with perfect information and the expected payoff and the risk, how to calculate the expected value of perfect information, EVPI, and understand sensitivity analysis and its calculation. So let us begin our decision-making analysis now. Influence diagrams. Influence diagrams are graphical representation of complex situations. Influence diagrams have many random variables, also called events, and one or more decision variables. They are more concise than decision trees because they do not show the alternatives at the decision nodes and states of nature at the chance events. Constructing and validating the influence diagrams improve communication and consensus building at the beginning of the decision modeling process. The following is an example of the influence diagram representing the decision of whether or not to introduce a new product. The circles show the random variable, also known as a chance event, and the rounded squares shows the payoff or part of it. This influence diagram for a new product decision involves a pricing decision. This diagram was produced by DPL software. Here, the key uncertainties are the units sold, which is affected by the pricing decision, fixed costs, and variable costs. Profit is the ultimate value, which is influenced by the total cost and the revenue values. Expected value of perfect information. Sometimes it is possible to know with more certainty which states of nature of the critical random variable will actually occur in the future. A decision maker may have probabilities for this state of nature. However, it may be possible to delay a decision until it is more clear which state of nature will occur. This might involve taking an option to buy the land. If the state of nature is favorable, the option can be exercised. If it is unfavorable, the option can be allowed to expire. The question to consider is whether the cost of the option would be less than the expected gain due to delay in the decision. Other possible ways of obtaining information about a random variable depend somewhat on the nature of the random variable. Information about consumer preference might come from market research. Additional information could come from product testing, or legal experts might be called on. The expected gain is the expected value of perfect information, or EVPI. EVPI is the difference between the expected payoff with perfect information and the expected payoff and the risk. To determine the EVPI, the decision maker can compute the expected payoff and the certainty and subtract the expected payoff and the risk as shown here in this formula. Calculating the EVPI. To calculate the expected value of perfect information, we need to find their components as follows. First, we need to find the expected payoff under certainty. To do this, we use the payoff table to identify the best payoffs for each state of nature. They are 10, 12, and 16 million. Since our formula will be using the EMV, we'll use the same probability of 0.30, 0.50, and 0.20 for each state of nature, low, moderate, and high. We then multiply each probability by their best payoff and obtain the expected payoff and their certainty to be 12.2 million. Second, we already have the expected monetary value to be 10.5 from before. So applying our formula, we will end up with the expected payoff under certainty minus the expected payoff under risk. The expected value of perfect information then is 1.7 million, which indicates the upper limit on the amount the decision maker should be willing to spend to obtain perfect information in this case. If the cost for obtaining additional information equals or exceeds the 1.7 million, do not invest on additional information and choose the highest expected payoff. Sensitivity analysis. Sensitivity analysis provides a range of probability over which the choice of alternatives would remain the same. This approach is useful when you have two states of natures. The graph provides a visual indication of the range of probability over which the various alternatives are optimal, and the algebra provides exact values of the endpoints of the range. Therefore, given a table with the states of nature number 1 and number 2, let us build our graph. Determine that the probability of 2 is the probability for the number 2 state of nature. Plot each alternative relative to the probability of 2. Plot number 1 payoff on the left of the graph and number 2 on the right of the graph. Connect these 2 points with a straight line. The 3 alternatives are now plotted. The graph shows the range of value of P2, or probability of 2, over which each alternative is optimal. For low values of the probability of 2, and thus values of the probability of 1, since probability of 1 plus the probability of 2 equals 1, alternative B will have the highest expected value. For intermediate values of probability 2, alternative C is best, and for high values of the probability of 2, alternative A is best. At the intersections, the 2 alternatives represented by the lines would be equivalent in terms of expected value. The decision maker would be indifferent between the 2 at that point. Sensitivity analysis calculation. To determine the intersections, you must obtain the equation of each line. This is relatively simple to do, because these are straight lines and they have the form of y equals a plus bx, where a is the y-intercept value at the left axis, b is the slope of the line, and x is the probability 2. These equations are displayed on the table. From the graph, we can see that alternative B is best from the probability 2 equals to 0, to the point where that straight line intersects the straight line of alternative C, and that begins the region where C is better. Therefore, to find that point, we solve for the value of probability of 2 at their intersection. This requires setting equation B and equation C equal to each other and solving from probability of 2. Thus, 16 minus 14 times the probability of 2 equals to 12 minus 4 times the probability of 2. Rearranging the terms yields 4 will be equal to 10 probability of 2. Solving yields the probability of 2 equals to 0.40. Thus, alternative B is best from the probability of 2 equals to 0 up to the probability of 2 equals to 0.40. B and C are equivalent to the probability of 2 equals to 0.40 as indicated in the graph. Alternative C is best from that point until its line intersects alternative A's line. To find that intersection, equation A equals C and solve for probability of 2. Thus, 4 plus A times the probability of 2 equals 12 minus 4 times the probability of 2. Rearranging terms results in 12 times the probability of 2 equals 8. Solving yields probability of 2 equals 0.67. Thus, alternative C is best from the probability of 2 greater than 0.40 up to probability of equals to 0.67, where A and C are equivalent. For values of probability of 2 greater than 0.67 up to the probability of 2 equals to 1, A is best. Module 6. The future of decision making. Human intuition can be astonishingly good, especially after it is improved by experience. Firefighters can, under extreme duress, anticipate how flames will spread throughout a building. Nurses in the neonatal ICUs can tell if the baby has dangerous infections even before blood test results come back from the lab. Examples like this give many people the impression that human intuition is generally reliable and that we should rely more on the decisions and the predictions that come to us in the blink of an eye. But the reality is that intuition is not reliable, and errors are made because, after all, even the experts are also human, and we are known for making mistakes that can even cost lives. In this workshop, you will learn about some of the evidence that make intuition not a very reliable tool for decision making. We will introduce to you how data is being used to drive decisions nowadays. We will introduce to you the importance of artificial intelligence in decision making in business and show the changes that are setting the future of the decision making process. Less intuition, more evidence. The lexicon to describe the intuition phenomenon is mostly mystical in nature. Intuition springs from a deep place that cannot be easily examined. We should rely less, not more, on intuition. Researchers has clarified much about how intuition works and how it does not provide the reliability needed by leaders to be effective. Here's some of what we have learned. It takes a long time to build good intuition. Chess players, for example, need 10 years of dedicated study and competition to assemble a sufficient mental repertoire of board patterns. Intuition only works well in specific environments, ones that provide a person with good cues and rapid feedback. Cues are accurate indicators about what is going to happen next. We apply intuition inconsistently. Even experts are inconsistent. One study determined what criteria clinical psychologists use to diagnose their patients and then create simple models based on this criteria. It is easy to make bad judgment quickly. We have many biases that lead us astray when making assessments. We cannot tell where our ideas come from. There is no way for even an experienced person to know if a spontaneous idea is the result of legitimate expert intuition or of a pernicious bias. So we have lousy intuition about our intuitions. Data-driven decision making. Big data trends are now embedded in mainstream information technology, IT. Nowadays, companies need to repurpose and perhaps retrain their professionals to operate in the data-driven world, and the reasons are obvious. Because the nature of work is changing, we are now seeing technology replacing the activities that management staff and knowledge workers were once performing. Decision makers still are not getting the information they need. Leaders struggle to separate out meaningful information from extraneous noise in their environment. New challenge for the next decade. The challenge facing companies over the next 5 to 10 years will be figuring out how to use the data that is available to them, refine it into information, and harvest that information insights to drive decisions. Transforming your workforce into data professionals. The keys to developing these workers into data professionals is providing them with access to data, the analysis tools to organize, work, and redefine the data that feeds the decision-making process. Setting your company and employees up for success. The future of work for the next decade will be focusing on managing data the company has today and helping the organization use it in new ways to solve problems and exploit the new opportunities. As we continue moving into a data-driven society, technology must continue merging automation and cognitive technology to make systems self-managing and potentially self-defending and self-healing against any risk. Artificial intelligence in business. Artificial intelligence is based on the principle that human intelligence can be defined in a way that machine can be easily mimicked to execute many tasks, from the simplest tasks to those that are even more complex. So how does Fortune 500 companies manage their contact center today? Well, using the following. Assisted intelligence. Assisted intelligence refers to the automation of basic tasks. Examples include machines in assembly and production lines. Using augmented intelligence. Because there is a give and take with augmented intelligence, giving artificial intelligence the chance to learn from a human input is of an essence. Therefore, we can make more accurate decisions based on that information. And using autonomous intelligence, which is artificial intelligence with humans out of the loop. Think about self-driven cars and autonomous robots. Artificial intelligence technology have been giving organizations the means towards effectiveness and efficiency, improve innovative capabilities, and to have better opportunities running their business for them today. Artificial intelligence in business. With the era of deep learning already here, executives today count on a database of models and simulations to turn for all kinds of analysis and decisions to be made. In the field of retail, marketing, and sales, all applications have provided a new and more reliable tool in market forecasting, process automation, and decision making. Several artificial intelligence applications in business has enhanced their decision-making flows. Marketing decision making with artificial intelligence. There are many complexities to each marketing decisions. Organizations must understand customer needs and desires, and to align products to these needs and desires. Customer relationships management, CRM. Artificial intelligence within CRM systems enable its many automated functions, such as contact management, data recording and analysis, and lead tracking. Recommendation systems. Artificial intelligence system learns a user's content preference and pushes content that fit those preferences. This can help you reduce products bounce rates as well as to craft better targeted content. Through expert systems, artificial intelligence has tried to replicate the knowledge and the reasoning of experts through so-called expert systems, which are a type of problem-solving software as follows. First, the creation of automation, efficiency, and artificial intelligence. Here, artificial intelligence has been able to hasten process and provide decision makers with reliable insight. Implementation of social computing, which helps marketing professionals understand the social dynamics and behaviors of a target market. And of course, opinion mining, which is a kind of data mining that searches the web for opinions and feelings, a way for marketers to know, receive feedback. Creating the future we want. Today, artificial intelligence is impacting the future of virtually every industry and every human being. Yet, artificial intelligence is only as good as the design of a cognitive algorithm and the data upon which that reasoning is based. Large warehouses from Fortune 500 organizations continue to automate their operations by powerful automatic guidance vehicles, picking and packing functions that were traditionally human work. Amazon has currently over 100,000 robots doing just that right now. We must continue making artificial intelligence improvements to better our animation patterns in everyday challenge. This should be done in all industries to continue striving for better decisions, better efficiencies, and better sustainable operations in all they do. Module 7, Wrapping Up. Although this workshop is coming to an end, we hope that your journey to improve your understanding on how leaders' decision-making process affect organizations when done right had been productive for you. We hope these tools gave you a better understanding on how the dynamic of decision-making process can be applied in your everyday life at work. We would like to send you our free forms that will help you set in your decision-making process future plans going. They are the situation analysis form and the ethical checklist form. Please request them via email at led.management.consultants@gmail.com. We would like to thank you for your participation on this workshop and wish you best as you continue furthering your leadership training to become the transformational leader your company expects. Reflecting on the workshop. This workshop provided you with important topics as follows. You learn about the mechanisms of decision making. We introduced to you many decision theories concepts, risks, and how to prevent poor decisions. You also learn how to choose appropriate alternatives and select their payoffs. You were introduced to decision-making techniques in different environments. You learned to evaluate alternatives according to payoff tables or decision trees. You also learned about the basic of probability and decision-making process. And we trained you on how to apply decision-making analysis and sensitivity analysis. And finally, we explained to you about the future of decision-making by introducing artificial intelligence and the future of automation. Reviewing your notes and action plan. This is the time to collect your notes, including your action plan for your organization. Review them one more time, only this time think out of the box and make sure that you are ready to apply your new systems knowledge in your organization. Remember, this plan will be the secret of your success in many years to come. With the completion of this workshop, your requirement core workshops come to an end. Good luck and be sure to enroll in your first specialty level workshop that will enhance your leadership power management and redefine your leadership influence in your organization. Do not forget, we are here for you. If you have any questions about this workshop or any leadership issue, please send us a note from our website located at www.leadershipemotionaldevelopment.com or send us an email at led.management.consultants@gmail.com. As always, for immediate needs, please call us at 803-881-8066 or 540-435-6964. Final words. This concludes the second core level workshop obtained from our systems theory group. Thank you for your participation, and we will be happy to help you reviewing and discussing your action plan. Call us and get your free consultation. We will leave you with some words from the wise.